later use. And for the students that aren't going to be here today, remember that the very last thing that you're going to do before you exit out of class today, after you're done with your exit ticket, is to fill in what you learned today. Something that was new or something that you need reminding of. Great things to put in this box include formulas. Formulas are huge. It includes vocabulary that we need to learn. Once you find something, put it on here. You know this is eventually going to turn into your final exam. So everything that you do on these sheets is giving you more points for your final. More points on the final. All right. Thank you guys for being so patient. What? Great question. Let me push pause on our video so we can talk through that logistics real quick. Okay. It's very much, we're going to review basically what we went through yesterday, because some of us have a little bit of trouble in the zone out department, so we want to make sure that we get all of this written down. How do you keep your brain engaged? Well, that's easy. You got to keep the pencil in your hand, and you got to keep the pencil moving. Two basic things to make your brain operate the way you want it to today. That's all we need. So, Mr. John, if you need to grab another binder from the back, they're free and they are blank. And you can grab one right back there as much as you need today. All right, on number 25, we're basically going to have a student council problem, okay? So student council is going to sell you either like a rose, or they can sell you like a little carnation. Now, they're different prices, of course, because they're different kinds of flowers. So we're going to charge you $3 for your rose. We're going to charge you $2 for the carnation. Mr. Case, how much change you got in your pocket right now? No pennies, no change. If you had quarters, nickels, and dimes in your pocket, about how much would you have? Okay, that'll work. So instead of cents, we'll use dollars. Let's use $25. This would be what we got in our pocket. About zero. Okay. Mr. Eric, do you know how many of these flowers that you can buy just yet? No. So what could you use the case in place of a I don't know? Like my I don't know is a question mark. What can we use instead of a question mark? Okay. Well, what if I buy 1? What if I buy 2? What if I buy 3? What if I buy 10? We're talking about roses first. Yeah. Okay. So we can do the math in our head, but what if I wanted to buy 3,000? Can I do that in my head easy? Yeah. No. So what can I use here instead of a number here? Yes. Now we're talking about total, receipt-wise, total money. So is this an addition or a subtraction problem? If we're talking about total? Addition, good. All right, if roses are going to be X, Alan, what can we use for carnations aquí? Tenemos aquí, por este flor. ¿Y aquí? No. Aquí está. Yeah. Here. And very last thing here. I got $25 in my pocket, right? Well, that's what we're saying. Well, it's 25 cents. 25 cents plus whatever. All right. Don't put that on me. I don't need it. Sorry, it's right on my pocket. Okay. So here's the question. Mr. Prashant, can I spend less than or equal to, greater than or equal to, less than or greater than $25? Which one of the 4 is what I can do with my $25?
Less than or equal to 25.
Perfect. Less than or equal to $25. All right. So now we have an equation And what we want to do is first solve for y, because we're going to graph this out. So we're going to have to solve for y here. All right, Mr. Edgar, ¿qué es el contrario? ¿Qué es contrario a positivo 3x? ¿Qué es el contrario a positivo 3x? Tenemos un positivo 3x. ¿Qué es contrario? Negativo qué? Muy bien, muy bien. Negativo 3x aquí y aquí. Put your negative 3x on both sides. And what this does, it keeps everything in balance. Because you got to keep that equation in balance. So we're going to bring down our 2y. Bring down our less than or equal to. Bring down our 25. Bring down our negative 3x. Good. Keep that pencil moving, guys. You're doing great. That's going to keep your energy together. Okay. And then we know that 3x and minus 3x, what Edgar just told us, is just going to be 0. All right, last step, Montre. What could you do here to help you out? Solve for y. That's it. Divide by 2. Cool. So y is less than or equal to 12.5 minus 3 over 2x. It does, yeah, because we're going to take 25 here, John, and we're taking 25 divided by 2. And that's 12.5. All right, guys. So, Mr. Krishan, which number here, 12.5 or negative 3 over 2, which number is going to turn into my slope?
3.8.
Is it x or the number in front of x that's going to turn into my slope? All right. So let's use the number in front of x, negative 3 over 2. Very good. That's going to count for our slope. All right. If negative 3 over 2 is our slope, Krishan, what's our intercept? If negative 3 over 2 is our slope, what is our intercept? 12.5. Intercept. Good. It is the y-intercept. Specifically, it's not an x-intercept. It's the y-intercept. Specifically, yeah. Perfect. All right, let's graph this. Mr. Allen. ¿Qué significa este número de aquí, 12.5? ¿Qué significa? Sí, es un y-intercept en mi gráfica aquí. ¿Qué significa este número? ¿Dónde está 12.5? ¿Está en X o Y? Y mira aquí, dice y-intercept. So that's what Krishan was telling us. So, Krishan, where should we start this graph?
Oh, wait. My number?
Yeah, what we're going to do is we're going to start it at the y-intercept, right? Because we know that that's an actual coordinate point. So let's go up to 12.5. Let's do 2, 4, 6, 8, 10, 12, 14. All right. And then we can go out to here, 2, 4, 6, 8, 10. Kind of same deal. All right, that first coordinate point Krishan just told us is going to be up here at 12.5, 0. All right, Mr. Edgar, do I go up or down? I've just finished my y-intercept. Now, do I go up or down with my slope? ¿Abajo o arriba con este slope? Abajo, muy bien. So, we're going down 3 units, down 1, down 2. All right, so if we need to go down 3 units, we're going to be at 9.5. That's down here. And then we need to go over 2. It's right here. Now we're going to go down 3 more units. So we have 12 minus 3, which was 9. 9 minus 3, which is 6. We're at 6.5. And when we go over 2, al lado 2. Menos 3, al lado 2. Minus 3, go down 3, and then go over 2. All right. Once you get your 2 3/4 points on there, let's grab your calculator now and go right onto the line. Create your line here. Now, are we going to have negative flowers? Can you sell me negative roses? Like if you walk up to the cashier and you say, I need negative 2 roses and 10 carnations. Can you do that? No. Yep. So do not draw a graph that goes negative. Make your graph stop here in the positive quadrant so that all of your flowers are positive. Do not go underneath these axes here because you can't sell negative flowers, right? Only positive flowers. Yep. It's got to stay in quadrant 1. You're right. All right, guys. Let's go on number 26 now. So again, just as a reminder, guys, we're going to go 25 through 31 and take a break. And then we're going to start our practice. So the reason why we want to do this, remember, you have 4 hours of a STAAR test. We're trying to train your brain to focus for a little bit longer, little bit longer, little bit longer. Each day, getting better and better at being able to focus for 4 hours. All right, number 26. Let's start it with the graph again, okay? Make your X and Y. And this time we're going to number by tens. So 10, 20, 30, 40, 50. And do the same thing. Por 10, cada caja es 10. So negativo 10, negativo 20, negativo 30. Yep. On your x-axis, just go out by ones. No big deal. 1, 2, 3, 4, 5. And go out 6, 7. And then you'll be done. Let's label over here. Your y-axis is grados. Celsius. Celsius. And this line here, this is going to be your height. And we're going to measure that in kilometers. Negative 10, negative 20, negative 30. Yeah, we're going to count by tens each time. Let me blow that a little bit bigger for you there, bud. Okay. Yeah? Now, this question is very straightforward. They're going to ask you to calculate the slope. So that's where we're going with this. So we need some coordinate points on the line. We got a coordinate point here at 2 and 0. So make that on your first coordinate point. We got a second coordinate point here at 7, negative 30. Down here. All right, make that line. This one, of course, can break the graph. We're going to have all different types of temperatures. So it's going to look like that. The only thing I can't have is negative distance, right? Like, at no point am I going to, like, go negative 1 kilometer or negative 10 kilometers. Doesn't make sense. All right. So we're going to calculate slope, right? And Mr. DeCaris, the whole point of doing it this way There we go. Hey. The whole point of doing this way is so that we don't have to do any math. We want to be able to do everything on the calculator today. So now's the time. Grab a calculator and let's get started. Come on over here in your calculator to where it says statistics. So press the stat button. All right. That's the first thing we're going to push is stat. After your stat button, you're going to go in and edit that list. So stat, edit. Now, mine already has data in there. Yours may too, or it may not. If it doesn't have anything in, you can just go and clear it out. Here's the trick. Go to the very top, guys. Once again, please put your cell phone away, Edgar. Go to the very top where it says L1. And then just hit clear. And then it's going to clear everything out for you. You can hit enter. And now you have a fresh list to start from. You don't need to go through the whole song again. All right. Let's put in your 2 coordinate points. We have 2 and we have 0. We have 2 and 0. What else do we have? We've also got 7. We got 7 and we got negative 30 down here. Negative 30. Okay.
That's a negative 30.
Yes, sir. All right. So we went to stat. And then we pushed edit. This is okay. How you doing? Okay. Pushy, pushy. We're trying to get your data into the chart. You know what I'm saying? Okay. Are we all there? Oh, okay, good. All right. All right. So now from here, after you go stat edit, you're going to go back to stat. And now we're going to go to calc. Go back to stat. Now go over to calculate. Okay. Now the last step here, come down to option 4. Press number 4. And then entrar.
So,
There you go.
what type of question?
If they ask you anything about slope. So probably about 50 to 70% of the questions, you're going to want to do this. Okay? No problem. Let's go back. It's no problem. Let's go back. We're going to pick up everybody this time. Okay, come back. Go over to stats. We're going to start up here in the top one. Stat. You're going to go into edit. And you want to put in the coordinate points that you have here on your line. We have 2, 0, and we have 7, negative 30. I didn't make them up. They're actually physically coordinate points on the line. Right?
Yeah, 30. Right? I'm working on it. If you do it this way, the reason I'm asking you this way, say it's energy because you're pushing. So it's going to be way closer.
All right, guys. So from here, we're on the second step. Stat, calculate, number 4. So go to stat, calculate, and then go down to number 4. Do you need the keyboard or the box? So in this one, again, now that you've got your coordinate points in, we have 2 on that one, and the coordinate points at 2, 0. Now the other one, we have 7, and on the other side of it, it's negative 30. All right, so you have all the coordinate points from the graph in there, and you're going to go back to stats. Go over to calculate, and then number 2. Those are all the answers. So, like, literally on the STAAR test, there will be one answer that says negative 6. Okay? So I'm trying to get that happening
so that you don't have to do a whole lot of work.
Maybe, I don't know, maybe it didn't do more. Maybe that's what will keep you awake. I have no idea. Well, whatever it's going to take, that's what we need to do for these next 5 days. Whatever it's going to be, that's how it needs to be. All right, guys. So we're just going to write down exactly what you see here. You see that ax plus b is our equation, so y equals ax plus b. We know that it's y equals negative 6x plus 12. That's because 30 is negative in your data. All right, what's up, bud? Yeah, I got you, man. All right, here. So now that we have our equation here, Montre, which one is it? Is it negative 6 or 12 that's going to be our slope?
Yeah. Oh, negative 6.
Yes, negative 6 is going to be our slope. Good. And that means that this 12 is our intercept. Cool. All right. So that takes care of our slope question. We need to calculate the slope.
So, like, it's going to be work on, right?
Yeah, this is how it looks on the STAAR test. Right? So they give you the graph. You take your 2 coordinate points. You put your coordinate points in the table. It spits back out the answer. You choose the answer that's closest to the estimate. Like 50 to 70% of the test is find the slope. So I'm trying to, that's why we keep practicing this over and over. Grab a coordinate point, put it in the table, make it do the slope, put the slope into the answer. So you got a negative 6 slope, right? All right, so negative 6.5 is right here because what it says is which of these best represents the rate of change. This is more of an estimation question. That's exactly right. Yeah, thanks for putting that in, John. We're going to put slope, and then underneath that we'll put rate of change. That is exactly how they're going to say it on the STAAR test too. They'll say, what's the rate of change? What's the rate? Good. Yeah, for sure. Yeah, that's going to come 28, 29. In like 2 or 3 questions. Yeah. And then we'll practice through those. All right, guys, 27. We're going to head on to 31, then we'll take a break. 27. All right, 27 is an awesome one. And John, to your point, this is the one where you get a bunch of coordinate points and you got to figure it out. Okay? So they're going to say that on 27, that y is directly proportional to x. Y is directly proportional to x. And what you really want to zoom in on, and that we've been practicing in classes, is direct proportion, direct variation business. That's the key vocabulary there. So they also give you some other information. When x is 140, y is 35. What they really want to know is that if x is 70, what is y going to be? Right? So, John, this is the exact question that you were just asking about. They give us some coordinate points. We've got to do something with it. And we're going to see this exact same thing happen here. We're going to put it into the calculator and make it spit out the answer for us. Yeah. Here you go, bud. It says the value of y is directly proportional to the value of x. If y is 35, x is 140. What is the value of y when x is 70? Well, yeah, good question. So that's what we're gonna do as a class right now. So y is directly proportional to x. This right here, this is your big vocab moment. We have talked about direct variation and indirect variation before. Direct variation. What coordinate point do I have to go through, Eric? It's going to be 0, 0. If it's direct variation or indirect variation, it has to go to the origin. Guaranteed. That's what we're talking about here with direct variation. Okay. So knowing this vocabulary word is what gets you the answer here. It's what gets you the other coordinate point. You got to know the vocab. But now we actually know this, right, John? We have a coordinate point here on an XY chart of 0, 0. And we also have one that's 140 and 35. The big question for us to answer today is what if X is 70? What will Y be? So that's what we're going to do. We're going to write the equation. After we write the equation, we're going to have to substitute in so here's our two steps. We're going to write the equation and then substitute. Only two things to do today. And Mr. John, you want to do this on the calculator? That's fine. All right, guys, let's go back and do on our calculator. So we're going to start the same process again. What's the first thing we need to push, Miss Jennifer? Stat. Very good. Go into stats. Now we go down to edits. Edit. Tenemos una lista, una tabla. We have a table here of 0, 0. So change the 2 to a 0 and hit enter. Change the 7 to the 140 and hit enter. Go over to the negative 30. Darwin, I need you to participate in class today. Every day you need to take in what we're doing so that you can practice. And change it to 35. All right, so Mr. John, make sure that your table on your paper now matches the table on your screen. They should be the exact same so that you can go into stat, calculate number 4, and then get your equation. Make sense? Okay. Stat, calculate. You okay?
Yeah.
Okay. Stat, calculate, and then go down to option 4. Enter, 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 enter. And there's all of your answers. Right? Let's write down what it's telling us. Y equals AX plus B. Now let's fill in our numbers. Y equals 0.25x plus 0. Eric, what's the last step that we're going to do here? What's step number 2? We just wrote our equation. What do we need to do? Yeah, what's this word right here? What are we trying to do? Yeah, we're trying to substitute into the equation. So we're going to take the 70 and substitute it. Good. All right, so this is the part where we substitute. We take our 70, and it goes right in for the x. All right, so y equals 0.25 times 70. All right, question for the crew here. Mr. Krishan, are you responsible for this math, or is your calculator responsible? Calculator's responsible. Let's do that. 0.25 times 70. All right, so we got 0.25 times 70. And Mr. John, when you put in 0.25 and then you multiplied it by 70, what came out? What does y equal? Perfect. And that's what we know. Now we know when x is 70, y is 17.5. Is this doing okay, Jennifer? Okay. This is from yesterday, right? So we remember? Okay. All right. Alan, how are we doing? Nope. Okay. We need some more practice on that. Majority, are we okay? Do we need some more practice? What do you want to go? More practice. Okay, cool. We can do that. All right then. Let's get some more coordinate points and practice. All right, guys. 28. 28. They're going to ask you to do some multiplication. We have 4 different multiplication problems. This is a different style of multiplication than you're used to. Because on 28, what we're going to do is something different. We're going to take a straight line, something that looks like this. And today's task is to multiply it by another line. This is new for us. We've always added and subtracted lines together, but now we're going to multiply lines together. Now, the whole reason that we do this, guys, is so that we can actually describe the real world. When you multiply 2 lines together, you get a curve like that. Many of you will notice this as a basketball being thrown through the air, a missile being launched into the sky, a satellite being blasted into outer space. All of these things that are very, very important for us as a growth as a human race, we can model them by quadratics. Most of this math for the space shuttle missions, when they were first getting started, was all done by hand. Once computers came about, it was done by hand, and then the computer verified. We still do it that way today. We always verify what the computer is telling us. So this is going to be a little bit different. We're going to get a line like m plus 10. And we're going to multiply it by another line like m plus 3. Now, many of you will already know that this is actually called the box method. You will understand that we're going to create some windows here. Inside of these windows, we're going to write our 2 lines, m plus 10 and m plus 3. Now, next semester, we're not going to call these lines anymore. We're going to call them factors. But for right now, we need to know that these are 2 lines that are going to turn into a curve because we're using multiplication. This is huge. Yes, this is a huge key point for us. We need to know this one. So, m times m times m is m squared. That's what this is. This thing right here is y equals x squared. It is a parabola. That's the equation of something like this. So that's why you're getting an m squared, because you're multiplying these 2 lines together. M times m is m squared. Remember, that is different than what we're about to do. What we're about to do is 3, nope. I'll make it a 2. A 2 times m, which is just 2m. So I want to make sure that you see that difference there. M times m is m squared, but 2 times m is 2m. These are different families, right? So John, the number family is in a number family, right? The m family is in the m family. They're 2 totally different families, right? So when we go to write our answer, both families are still there, right? Okay. Now let's go back to this one. This is the m family, right? This is also the m family. They're in the same family, right? So because they're in the same family, we write how many there are up top. These are not in the same family, so we have 2 different things. This is the number family, right? This is the letter family. They're 2 totally different. For this box. That's right. We're doing m times m, and we get m squared. This one right here? Oh, let's do that box too. John, what is 10 times m? 10m. Good. Montre, what is 3 times m? 3m. Good. And now we have this last box here. Krishan, what is 3 times 10 here? 30. Good. All right. Now, Krishan, what we're trying to do here is actually just say, what's up? We're trying to put this equation together at this point. We have an m squared. Now we have a 3 and a 10. A 3 and a 10. John, what is 3 plus 10? 13. Good. So put a 13m there. right? Because you're adding. We have 3m and 10m, right? 10 plus 3 is 13m. This is a 1m squared, right? This is a 1m. This is a 1m. I know. Trying to get that math together. That's what it's like. I did put plus 30 at the very end, right? Because that's what my grade just told us. Or 10 times 3 is 30 here. Sorry, Christian. Yeah. All right. Well, we're gonna do some more practice. Yeah. Practice. All right. Right. So you had to put these two lines together, right? You multiply them and then you put them together into an equation. The m squared here. Yeah, we got that because we multiplied m times m, right? M times n is m squared. It's Punnett squares. It's exactly it. So what came first, math or biology? Math. And Gregor Mendel used math to invent Punnett squares and to cross-hybridize pea pods. And that's how we have recessive and dominant genes. So because of this. That's where it's coming from. That's why we have biology. That's why we have history. That's why we have all those other things. It comes from ELA and math. That's why those are your 4 courses. Oh, yeah. We need to be launching shuttles into the outer space. We need to be calculating when the missile is going to hit the ground, how fast the ice caps are melting. All those things come from our geometry and algebra practice. All right, m plus 15 and then m minus 2. Now it's time to start practicing. If you already know what to do, go. Go, 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 go. If you need to work with me, just work with me. I'm going to talk aloud as we do this. All right? So, same thing. We're going to take a Punnett square here. We're going to take a ventanas, a little windows here. Alan, por favor. All right. And we need to write, primero, we're going to write m plus 15 here across the side. This one, m minus 2? Yeah. And this is m minus 2 that we get to write across the top. Is that better? M times n? There we go. Remember, these are the same family we're multiplying. So we're just going to throw the exponent up top. Remember, these are two different families now, right? This is the number and the letter. Negative 2m. Yep. And what about the next one? 15 times m, right? There you go. And the last one is 15 and negative 2. Positive or negative, though? Okay, but I have a positive 15 times a negative 2. Everything is times, right? Because we're using multiply here. How you doing? All right, so build your equation together. We have m squared minus 13m minus 30. No, plus 13m. Is that right? What'd you get, Eric? Plus or minus 15, or plus or minus 13m? Is it plus or is it minus the 13m? It's plus? I don't know. Eric, explain it. Why is it 13? I'm going off of you. 15. Okay, so we have a 15m, right? We also have a negative 2m, right? Cool. 15 minus 2 is 13. Edgar, how we doing? Okay. Yeah, just make sure that the sign comes with you into the box.
Alright, so the answer, all you gotta do is make sure the sign goes with it.
That's it.
And then,
You got it.
alright, so an answer, it's gonna be either minus or subtracting whatever those two are.
Yes. After we multiply, we're going to combine everything inside of the box for one final equation.
So that was positive would be m2
17.
plus 17n.
Brilliant. Brilliant. Yeah. Brilliant. Yes. That's good. That means geometry is going to go well for us too. Not just algebra, but geometry as well. Let's practice on two more real quick. Okay. We got n minus 10 and then n minus 3. Practice on your own on these two. We're also going to do an m minus 15 and an m plus 2.
With times in two.
Yeah, come on. All right, do your setups over here. M minus 10, M minus 3. Do your other setup over here. Porque es multiplicación. Usamos ventanas con multiplicación. Dos líneas. Multiplicación. So M minus 15 and then M plus 2. Tenemos 3 minutos por practicar, por favor. Okay, guys. Dos ventanas. Let's work on our 2 windows. Figure out your multiplication on the inside, please.
Relax, you come back together. Relax you for a second. Come back together. We're in a different part now. We're starting to learn curved lines and all that kind of interesting stuff. It's not really these straight lines anymore. So if we do elevado.
What is 10? Okay, so B. Three.
So these are different families. We just but this one over here. Letter family. The letter family. We have M. M squared, M to the power of 2. So same family, x1. Different family, 9. So we have negative 10 times m. We have negative 10 times m. So that means we have negative m. Pero aquí tenemos 6 y 10. Bueno, lo que es 10, 3. Okay, nothing. Last few seconds, guys. Last few seconds. I'm going to check your work, and then we will be done. Okay. Yes, this is the one to get. All of this is correct. Yeah, you need to write your final equation. That's like the end zone. Put the football in the end zone.
Alright, so I'm going to copy down some of what I saw off of Alan's paper real quick. What I saw from Alan was m squared. I saw minus positive 30. So this last one, Mr. Edgar, I have an m squared. ¿Qué es eso? Negativo 10, negativo 3. ¿Qué es eso? Negativo 10, negativo 3. Cool, that is negative 13 when we put it together. All right, the very last one is going to be a positive 30. Okay? Cool. All right, Miss Aguilar, help us out on the second windows that we're doing here. I have m times m, Miss Jennifer. What's going on in this box up here? M squared. Mr. Edgar, I have 2 times m. So what's going to go in here? Okay, we already have that one. What's this one? We have 2 por m. Okay, it's fine. Look, we had negative 3 times m, right? And we came out with negative 3m. Over here, we had negative 10 times m, and we came out with negative 10n. Okay? So here we have 2 times m. What should we come out with? What number is this? Okay? What letter is this? You don't know the letter? Okay. Perfect. There we go. That's all we got to do, right? Yeah. All right. So, Darwin, next one up. Negative 15 and m. Nope. Darwin. Aquí tenemos 2. Escribe 2. Tenemos m. Escribe m. 2m. Aquí tenemos negativo 15. ¿So? Sí. Luego tenemos m por m. ¿So? Aquí. No. M está una letra. So. No hay un número. Solamente m es mismo. ¿Sí? Porque números y letras son en familias diferentes. ¿Tienes? Diferentes. Aquí hay un número. Aquí, letra. Son familias diferentes. No hay, m igual 5, so 30. No. Solamente copia. Negativo 15, m. Copia. ¿Ok? Y luego, si m igual 12, está bien, sustituir. Pero es luego. Okay. All right, so now, last one, Monterey, we have negative 15 times positive 2. Negative 30. Miss Aguilar, put it all together in one final equation for us, please. What did we get? Literally, all we're going to do is copy whatever number you see. We're going to copy it straight into the calculator, and it's going to tell us what to do. If we are unclear that a negative sign means subtract, if we're unclear that a positive sign means add, we don't have to actually know that for the test. We just need to put it into the calculator so it can do the operation for us. So what I always see is if I see a minus, I know that to me that means subtraction. And if I don't see a minus, like this 2, I know that it has to be a plus, right? Like addition. Even though we don't write it, we know it's positive. I would put whatever you see in this box, I would type it into the calculator, like exactly as you see it. Yeah. Unfortunately, though, what we need to be aware of is that this is a positive 2, right? And you had to have typed in a negative 2 into your calculator to get to negative 17. So remember, what we're trying to do here is literally type exactly what you see here into the calculator, right? So let's start out, Ms. Aguilar, with negative 15. And then the next thing we're going to type in that calculator past negative 15 is going to be a positive 2. Perfect. And then what comes after the negative 13? It's going to be the letter M. right? Because we don't have just 2 and negative 15. This is 2m. This is negative 15m. So if we're counting m's, I have negative 13 of those m's. If we're counting just numbers, I have negative 30 of just the numbers. Now, if we're counting just m squares, I have one of those. Yeah? And so now we have a final equation using everything in the box. Put everything all together. M squared minus 13m minus 30. That's what you're looking for. Good practice here, guys. Alan, I'd like you to put your cell phone away so that you can check your work and make sure that you're actually going to be able to be successful in this on the STAAR test. All right, y'all, you're doing great. You're hanging in there. We've got just 1 or 2 more problems, and then we take our break. It's going to be a longer break to give you some energy, okay? Let's look at number 29. Ooh, we're going to have to say false on that. Sorry, guys. We're going to have to say false. With the way the time is working out. And we're going to label by 4s. So 4, 12, 4, 8, 12. 4, 8, 12, 16, 20. And do that on both x and y, okay? 4, 8, 12, 16, 20. All right, so first one, you want to circle your coordinate points, okay? Circle your coordinate points. We're going to go to 4, 8. That's this one right here. We're also going to go to 20, 0. Sorry, allowance 2. All right, from here, put a line down and then label this line as line 1. This will be labeled line 1. All right, now let's work on line 2. Line 2, they just give you 2 coordinate points to start. So, I guess we're going to have to graph it. But here's line 2. They gave you negative 12 and 20. And they give you 4 and 12. All right, so here's what we're going to do. Now we have line 1. We're actually going to take line 2 now and put line 2 onto our graph. All right? So we're going to take line 2, which is negative 12, 20. Negative 12 is 3 spaces out. Negative 12 is out here, 3 spaces. And 20 is just right up here. All right. When you put your coordinate point down, maybe box it this time so it's a totally different look than that circle coordinate point. Okay. The only other one they give us is 4, 12, so let's go and do that one too. It's right here for me. I'll box that one in. And of course, it gets its line 2. So we're going to put your calculator down and then draw your line. All right. So it should look kind of like this. We can say this is line number 2. And they give us 3 options, guys. 3 options. We have option A. There is 1 solution. We have option B. There are no solutions. And we have option C. There are infinite solutions. How do we know we have a solution, Eric? Yeah, how do we know if we have a solution? Like, what will it look like on a graph? The cross. Okay? So solutions, good, Eric. Solutions are where the lines cross. All right, so number 29, are these lines going to cross? Montre? No, these lines will not cross. So will we have a solution if they never cross? If we know that the solutions are where the line crosses, and then Montre told us that the lines never cross, will we have a solution? What do you think? Yeah? We'll have a solution. Okay, so let's go back and let's really make sure we understand what we're saying. Solutions happen when two lines cross. Montre told us that these lines are parallel. They will never cross, just like railroad tracks. So will we have a solution for this particular graph? What do you think, Mr. Montre? No, there's no solution. Thank you. And there's no solution because they never cross, right? All right. So that's what we're going to put down here. We say no solution. The lines never cross. Yeah, all right. So let's talk through parallel perpendicular just real quick now that we're here. All right, let's talk about some examples of parallel lines. All right, parallel. Pretty basic for us. Parallel just means we have the same slope. So Edgar, when you're writing in your notes, underneath parallel, Mr. Edgar, when you're writing in your notes, we just want to put underneath parallel that these have the same slope. So something helpful here would be like y equals 3x and y equals 3x plus 2. These lines are parallel because you have the same slope. You'd also have, other kind of examples. Y equals 1/2 x plus 2. Y equals 1/2 x minus 3. Of course, anytime you get those same slopes, those lines are parallel. We can also touch on perpendicular. These are perpendicular. Perpendicular, which means that they have one solution because they're going to cross in one place. Just a special type. So some really good examples of perpendicular lines. Y equals 3x and y equals -1/3x. Definitely perpendicular. We went from a positive 3 to a -1/3. Those are perpendicular. Another example, we have y equals 1/2 x plus 2. Just like we had up here. A perpendicular line to this is just y equals -2x plus 2. And we can write it like that, if that's going to be helpful. So again, here, the same thing happened. We went from a positive 1/2 to a -2/1. Right? You just flip in the fraction and the sign. These are called the opposite reciprocals. All right, last one is number 30. That'll kind of get us out of our review and get to start the new stuffs. Number 30 is just a straight up domain and range kind of question. So all we need to do is write the equation out and then figure out what it looks like for a domain and range. All right, guys, number 30. You need some more time? Está bien, pregúntame. Dice, señor, por favor, espera. Está bien. But I will not know unless you ask. Okay?
Graph.
Yeah, we don't need a table. We just need the graph. So you can push the button. All right, so let's talk domain and range. Mr. Allen, domain, ¿es that X or Y? Domain, X or Y? Muy bien, domain es that X. Range is that Y. All right, so to Montre's point, what we're going to do is just make that table. And the X side, we're going to call domain. The Y side, we're going to call range. So yeah, let's take a look at our table. Go to second on your calculator, the blue button, and then press your table. Top right corner there. Yeah, get to your table there. All right, so Ms. Aguilar, we see positive numbers on the domain side. Do we see any negative numbers on the domain side? We do. You just need to push the button, right? Like push buttons on your calculator to make it work. We see negative numbers too, right? Cool. So I'm going to put both positive and negative numbers here on my domain side. Let's switch over to the range side now. All right, so Mr. John, look on your range side. This is the Y side of the table, right? When we go over here, what kind of numbers are you seeing in Y? Are they positive or negative? They're negative right now. Okay, when I go over here to where X is -3, what happens? Yeah, when X is -3, what happens to Y? It turns from what? It goes positive. Good. So we're going to put that down there. Keep going, John. Keep going. Go down, go down, go down, go down. What's happening to your X values as they get bigger? What's happening to Y now? They go negative again. That's very important to have on your domain and range because something's really going to change here with these answers. All right, so your domain is negative to positive. And when you look at your graph, it's kind of like frowny face kind of thing like that. All right, so let's write it out. Domain. Put your X there, right in the middle. X is in the middle, like right here. X is in the middle. All right, so when we look out on our x-axis, we know that these arrow markings mean go, 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 go. So I'm looking for my x values, -10, -100, -1,000,000, -infinity is all the way out here, -infinity. I'm going to keep going to my graph. It's going to keep giving me negative. So put your -infinity right here. Let's do the other side. Mr. John, if this graph I know on the x-axis is going to give me to -infinity, when we go on the other side, what is this arrow marking going to do? It's not going to be -infinity. What's it going to do? What's on this side? What kind of numbers? They're positive numbers. So what's all the way out here past +100, +1,000,000? We can keep going. +1,000,000,000 is the x value. +1,000,000,000,000. What's past that? Infinity. Yeah, good. So put your positive infinity right there. Good. So now we're just going to say that x has to be between those two. So put your signs. Less than or equal to, less than or equal to. Put your signs in there. X is now between -infinity, positive infinity. Good. So now you've written your domain. We're going to do range next. Range now is on the y-axis. John, you told us something interesting was going to happen. It's negative, positive, negative. And that's what we see here, right? We have negative, we have positive, and we have negative. All right. So range is on the y-axis. John, what is the smallest possible y value that you could have? Okay, zero's right here, bud. My graph goes -1, -2, -3, -4, -1,000, -1,000,000, -1,000,000,000, negative infinity. Very good. Cool. All right, now on the other side. We come up here. This is going to be more of an estimate. But what is the biggest possible y value you can have on your graph, John? Yep. Okay, positive infinity is like way up here, bud. Way up here. Look at my graph. Look what happens. So it's like 1, 2, 3, 4, 5, 6, 7 kind of thing, like in there. 7, call it 7. I'm gonna call it 9. That's the actual answer. But yeah, 7, 9, somewhere in there. It can't be 10. It can't be 11. It can't be 12. It can't be 1,000, 1,000,000, or infinity because it stops getting bigger right here. And that's what I wanted you to see, John. This right here is why you're gonna have a number here and not infinity. Because you go from positive to negative, negative, positive, negative. Right? So you're going to have a big number there. Not infinite. Cool.